Staring out into the blackness of space fills us with a sense of wonder as we contemplate the mysteries of the universe. With so much out there, why does it appear so dark and empty? Light in its basic form is a type of wave, not all that different from the ones seen in the ocean. However, light is radiant energy that has to originate from an object. Humans need light to be able to see, and its absence results in complete darkness. We can see only a tiny part of the much larger electromagnetic spectrum, conveniently called visible light. This portion of the spectrum includes the colors of the rainbow, from red to violet. As mentioned earlier, light has to start from somewhere. In the context of astronomy, stars are able to produce light particles through the release of energy in their core. As two hydrogen atoms fuse into hydrogen, the resulting reaction produces both heat and light. Those light waves then move away from the star at 983,571,056 feet per second through space. At around 93 million miles away, light waves take just 8 minutes and 20 seconds to travel from the Sun to the Earth. Although there are countless objects in the universe, not every one of them is capable of producing light. Since it takes extreme pressure and temperatures exceeding 10 million Kelvin in the core to achieve nuclear fusion, many cosmic entities don't make the cut. Any rock in the solar system or beyond may be big enough to have a molten core, but will never achieve temperatures anywhere near that of a star. Thus, rocky planets and moons do not emit any light of their own and instead rely on light from stars to be seen. Interestingly, the large planets in our solar system, such as Jupiter and Saturn, do generate a faint amount of light on their own. While quite small compared to what a star can do, these planets are large enough to use the strength of their gravitational pulls to create light waves. Why is the daytime sky full of light? To understand why there's no light in space, it is beneficial to first understand why there is light on Earth during the day. Unlike the vacuum of space, the Earth claims an atmosphere full of many different types of gas molecules. Thanks to the Sun's proximity to our Earth, we get a lot of light from its surface. When those light waves hit the molecules in our atmosphere, blue and violet are just the right length to scatter. This results in a blue sky and allows light from the Sun to cover the side of the Earth facing it. As quickly as it rises, the Sun sets at the end of the day. Since light waves travel in a straight line until making contact with something, it's not possible for those same waves to reach very far into the side of the Earth that can no longer see the Sun. Without the Sun, we're left with the darkness of space that we all know so well. When the Sun is out of the picture, thousands of other stars come out to play. Why don't these stars produce the same effect as our star does? The simple answer is distance. After the Sun, the nearest star to Earth is Proxima Centauri, located 4.25 light-years away. This means it takes light traveling at 983,571,056 feet, 299,792,458 meters per second for 4¼ years to reach us. When light leaves a star like Proxima Centauri, it doesn't just head in the direction of Earth. It goes in every imaginable direction. The light that finally arrives on Earth is a very small fraction of all the light that the star emits into space. Because of this, stars just look like small points of light. With every star shining bright, this means there actually is quite a bit of it in space. We humans are only able to see sources of light that directly enter our eyes, so those beams of light that leave stars in other directions remain invisible to us. With so much emptiness in space, there's nothing for that light to bounce off of. There's actually quite a bit of light flying through the universe, but very little of it makes it to our eyes. We're very limited in what we can see from Earth, and there are countless objects too dim to offer us enough light to locate.